Alright, so in the previous video, we took a look at atoms and how atoms are made up of protons, neutrons, and electrons. And I told you guys a pretty easy way to remember it. Positive protons, neutral neutrons, and negative electrons. Now, positive protons have a mass of 1 atomic mass unit. That's just a unit of measurement. Neutral neutrons are also 1 atomic mass unit. And negative electrons have a mass of very small, roughly 2,000 times smaller than the other two. Now, these are all stuff that we covered in the previous video. This video, we're going to take a look at ions. So, with ions, we're going to take a look more specifically at positive protons and negative electrons. Now, as you'd guess, neutral neutrons, they have a charge that's neutral, right? So, neutral charges probably don't affect atoms that much because their charge is neutral. But these positive charges and negative charges are quite important. So, if we take a look at an atom, let's take a look at fluorine. So if you look at the periodic table, you'll notice it's made up of a bunch of squares like this. And each square will consist of an element. We'll cover this in coming videos, but an element is made up of one type of atom. So this is what we call an atomic symbol. We're going to look more in depth into this in coming videos, but this is an atomic symbol, part of the periodic table of elements. And the F is the sign for fluorine. On top of it, we have a large number. The larger number is the neutrons plus protons. And the bottom number, 9, that's the atomic number. So this is the mass number. The mass number tells us the neutrons plus protons added together. And the number below it, the smaller number, the atomic number, tells us the number of protons. So to calculate the number of neutrons, you just do the number of mass number minus protons, because that'd get rid of the protons, leaving you with just neutrons. But I told you, we don't really care about the neutrons. We're going to focus on protons and electrons. So how do we calculate the number of protons? Well, in the periodic table, and it's what it is in its default state, the number of protons is equal to the number of electrons. Now, what this means is that we have the same number of positive protons and the same number of negative electrons. That's what it is in the periodic table. So if you have an atomic number of 9, there's 9 electrons and 9 protons. That means 9 positive protons and 9 negative electrons. So 9 positive protons minus 9 negative electrons will leave you with a net overall charge of 0, right? Because the 9 positive protons will cancel out the 9 negative electrons. So if you draw a diagram to kind of explain this in more detail, we can have fluorine in the center like so. So this will be the protons in the center. And there will be 9 protons in here. And 9, we don't know the number of neutrons because we'd have to do 9 minus 18.9. 18.9 minus 9. It's going to be like 9.9 or something. But anyways, we have our 9 protons in the what's it called? The nucleus here. So the nucleus is made of protons and neutrons, and we have 9 protons in the nucleus. Now, as we covered, there's an equal number of protons and electrons. That's the same for all elements of the periodic table. So if we have 9 protons here, so I'll just write 9 protons, 9 pro, and we're going to ignore the neutrons because we don't care about it for now. Electrons, we're going to have 9 of them too, right? Now, the interesting thing about electrons is that we fill them in a clockwise manner, one at a time. Now, as we covered previously, this is a shell, right? The electrons surround the nucleus in what are called shells. Now, this is the first shell. The first shell can hold a maximum of 2 electrons. But the second shell and the third shell, so onwards from the second shell, can hold a maximum of 8. Now, the way we fuel these electrons up is clockwise. We go clockwise from the top, one at a time. So we currently have 6 electrons, 7, 8, 9. So we have 9 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice I filled them in a clockwise manner, one at a time. And we have 1 electron left. So what atoms want to have is they want to have a full outer shell of electrons. They want to have a full outer shell of electrons. So as covered previously, the first shell can hold a maximum of 2. So if this, say fluorine only had 2 protons and electrons, then it'd already be full, and that would mean it is stable. So it's unreactive. But when it doesn't have a full outer shell of electrons, the atom wants to like react with other atoms to get a full outer shell of electrons so that it can become stable. So currently it's quite unstable and it is very reactive because it wants to get a full outer shell of electrons. So it's currently missing one electron, right? So what will happen is, so atoms will try to take the fastest way to get a full outer shell of electrons. This fluorine atom can either lose its 1, 2, 3, 4, 5, 7 outer shell of electrons, or it can just receive one. What's easier? It's easier to just receive one electron, right? I'll mark that with a circle to differentiate it. Now, once it receives this one additional electron from another atom, it becomes an ion. Now, what this ion means is that we currently have 8 plus 2. So we currently have 10 electrons. We have 10 negative electrons. Remember, these are negative. And we have 9. We still have, because the number of protons, what the number of protons tells us is it tells us the type of element it is. So if it has 10 protons, it'll be a different element. So the number of protons never changes. So it's going to be 10 negative electrons and 9 positive protons. So there's fewer positive protons than the negative electrons. So these will cancel each other. These will try to cancel each other out. Previously, it would have been equal, right? Leaving a net charge of 0. But there are more negative electrons than positive electrons, right? There is one more negative electron marked with a negative. So it has a 1 minus net overall charge. That's it. Because there is one more negative electron than positive protons. So there's going to be, so all the 9 electrons are going to cancel the 9 protons, but there's going to be 1 electron remaining, leaving an overall net charge of 1 minus. Now the minus sign comes after the number. That's just the way it is. So it has an overall charge of 1 minus. If we take a look at, let's say, this isn't a periodic table atom, but let's say this atom had 5 protons, and it would have 1, 2, 3, 4, 5. Remember, we fill them out in a clockwise manner. 1, 2, 3, 4, 5. 5 protons and 5 electrons, right? But this currently doesn't have a full outer shell of electrons, right? So what does it need to do? It wants to get a full outer shell. So it can either receive, so it currently has 3 out of the 8, so it can either receive 5 electrons, or it can get rid of these 3 electrons. What's easier, getting 5 electrons or getting rid of 3 electrons? It's lazy, like us. It wants to get rid of it. It's the fastest and easiest method, right? So it's going to get rid of these 3 electrons. Once it gets rid of it, before it would have been 5 protons minus 5 electrons. 5 positive protons minus 5 negative electrons, leaving a net charge of 0. But now, there are 5 protons minus, how many electrons are there? Well, the 3 are gone to make a full outer shell of 2. 2 negative electrons. So 2 of these positive protons are going to cancel out these 2 negative electrons, canceling out the electrons, but there's still going to be 3 positive protons remaining, right? Because 5 minus 2 electrons is 3. So there's going to be a net overall charge of 3 plus, because there are now 3 more positive protons than negative electrons. So what ions are is when an atom loses or gains electrons to either have a net negative charge or a net positive charge, it becomes an ion. When the atom is in its default, like periodic table state, when it has a net charge of 0, because there is an equal number of protons and electrons, then it's not an ion. But once it loses or gains electrons, because remember, the number of protons cannot change, it determines the element. So the number of protons always stays the same. But when it receives electrons or loses them, in order for it to have a full outer shell to become stable, it becomes an ion, because then there is now a net negative or a net positive charge, because there are either more protons causing a positive charge, or there are more negative electrons causing a net negative charge. I hope this explains a bit about ions, and I'll see you guys in the next one.